Welcome to General Structures 2 and Lateral Forces, Lesson 3, Example number 1. And they are asking us to find the forces in the members of the truss shown on the next page. And this may be a 2-video answer because usually these take a little while. So I'm assuming that they want us to do the method of sections. Actually, it says method of joints at the top. So we're going to do this by the method of joints. And what the method of joints are is you first find your reactions, and then you go in at some joint, you cut it. Just so you kind of have you cut the joint, and then you figure out what are your internal reactions, or not, I won't call them internal reactions, internal forces of these members. And then you bring the member up here, you do it to the next joint, you bring it down here, you'll do it to the next joint, you bring it up here, and then so on. But as you can see, this one is symmetrical, so it will be symmetrical, and therefore you won't have to do this half of the span, I guess, or that half of the members. So let's go ahead and get started. I always believe it's the easiest thing to do is just go ahead and throw it on out there. If you remember your trigonometry, you'll know that this is 45 degrees. This is 45 degrees. That's, I forget what it's called. It's like opposite adjacent or opposite opposing lines. These are both parallel, and these are opposite. Therefore, they're equal. So if you have 45, 45, and that's 180. So 180 minus 90, which is 45 plus 45, equals 90. So you have a right angle. You will have a right angle because this triangle has 180 degrees. Minus 45 equals a right angle, and then a right angle up there. All right, so all of our angles are labeled, which I like to do. Just makes it easy, and then we can go ahead and get started. Okay, first thing we know that RAX equals 0. And if you go up back to the diagram here, it shows a pin on the left side and a roller on the right side. And once again, this is typically how that theoretically works out. You will have an RAX as well, but as we see, there aren't any loads going in the horizontal direction, so that means that RAX equals 0. Easy enough. And then we want to find out what RAY and REY is. To do that, you simply look at it as you would a beam. And I think we've done these before, but you just look and you sum the moment about this point right here, which isolates REY because RAY times 0 feet is 0. So we want to sum the moments about A, or you could sum the moments about E, and that would isolate RAY. We're going to choose to I'm going to choose to sum the moments about A, and you could do it the other way and see if it works out. So I'm going to do sum the moments about A equals 0. I'm going to call out this as positive, this direction. It's a positive moment. So let's start from the left and go to the right. We have, hopefully you know that this is going to be halfway, 20 foot, this is halfway. I'm not going to get into that, you should know that. If you don't worry. Just use your trig identities and figure out what this distance is. What I'm talking about is halfway, is this distance right here. It's going to be 10 foot. Actually, it is 10 foot. Shoot, sorry, I had it up there. I wasn't paying attention. All right, and first thing we want to do is say, well, RAY times 0 is 0, so we're not going to put that on there. And then you go to the right, you have 5 kips times 10 foot, which 10 foot's right there. We want to keep going. And it's going to be 5 kips. And remember that is a positive moment because it's going that way. And then we have another positive 5 kips times, this time it's going to be 30 feet because 20 plus 10 is 30. And then we're going to have a negative, and I like to do this, I like to add a negative REY, and that's going to be multiplied by 40 foot. And that will equal 0. And I'm not going to go through the math here. But because I know you're going to have, actually I will do something real quick. You're going to have this is positive, this is negative. You're going to end up adding this over here, so it's going to make it positive, and then you're going to divide by 40 foot. Alright, I said I wouldn't do the math, but I just showed you. And if you don't understand that, go back and look at the general structures videos, the original videos, and you can figure out, and I go through all the math steps so it's easy to follow. I'm going to assume that you know how to do that. If you don't, please go back. So let's use the calculator. 5 times 10, which is 50, plus 5 times 30, which is 150, I believe, equals 200, divided by 40. And we get 5. And this makes sense because, as I said, 5 kips. Sorry, not 5 foot. This structure is symmetrical. Oh shoot! When I go back, I actually look and it's 3 kips. Son of a gun! This one's 3 kips. It's not 5 kips. So I am not right. Actually, I'm right. I hope that makes sense because this is symmetrical the way I drew it. This should be 5 kips. That should be 5 kips. That makes sense. But this is not 5 kips. That is 3 kips. I wasn't paying attention and close enough. 3 kips. So we need to start over. But it's the same type of thing. You're going to have 0. We need to go back down here, change this to 3 kips, and we'll get this again. Sorry about this mistake. But it's easily fixable. Alright, so let's do the math again. 3 times 10 plus 5 times 30 divided by 40 equals 4.5 kips. 4.5 kips. And then we want to sum the forces in the y direction, and that's going to be equal to 0. And if you want to put the force goes up like that, sometimes I did that when I was in school, and it's a good habit to follow because in essence, if you have more of a continuous band, you can have uplift force at your reactions. So just a note: if you want to put the direction it's going, that's not bad. Or maybe you just want to put a negative when it's a negative, and you'll understand that as well. All right. So anyways, this is going to be a positive. We want to start from the left. We know that REY. Actually, let's start from the right. And we know REY equals 4.5. That's a positive 4.5. Then we have minus 5 kips. Then we have minus 3 kips. And then we have a positive. We're assuming. Remember, this initial assumption is positive. And that's all right. You can assume whatever you wish. A lot of people like to keep positive sign convention, which is usually smiling, which is positive moment. So if a beam looks like that, that means it's smiling, positive moment. That means you're putting this type of moment on it. So people over here will put that type of sign. Over here they'll put that type of sign. And then shear, they'll have the convention for axial is typically out is positive, and that's always going to be in tension. And if it's negative, that means it's going to be in compression. And I think I talked about some of that in the older videos. And then they also have positive shear, and shear is make it spin clockwise, I believe it's like this. And then if you have something else over here that's connected, let's say you cut a piece over here, that's down and this is up, and they're equal and opposite. I hope you understand what I'm saying right there. If not, don't worry about it. It's not the most important thing in the world, and it might just confuse you. I don't want to do that. All right, so back down here, we have RAY equals what? And we don't need the calculator. We can see that if you have 5, that's going to be negative 0.5 minus, that's going to be negative, or 3.5 kips. And that is also going to be up. And you can go through math, make sure I'm right. But if you look at them, you look at 4.5 plus 3.5 equals what? 7, 8. And 5 plus 3 is 8. So it should be good. So let's go ahead and put those up here, because I'm going to get rid of this so we can start looking at the joints. We have RAY equals 3.5 kips, and REY equals 4.5 kips. And hopefully that makes sense. You can take a look. Oh, well, I have more load over here. I have less load over here. More should come to this side. And I think that makes good enough sense, and my math works out, so I'm going to call it good. Now, next thing you do, method of joints. You just go to joint to joint to joint. And I've said that before, but saying it again is important. This is one of the ways I used to like to do it. Now I've gotten more into engineering, and I end up feel a little bit more doing the method of sections, and we'll show you that. And then I think the next video, example number 2 is over the method of sections. I'm looking at it right now. All right, so I will start at joint A. Remember, this is 0, so I'm just going to get rid of it. Actually, I'm just going to get rid of it like that, and I believe that's what they did on the diagram. I just wanted to make that clear that that is a pin, and in some certain circumstances, you cannot always assume that you have just vertical forces, because in a lot of times you're going to have horizontal forces too, longitudinal forces or whatnot. Alright, so moving right along, let me go ahead and change and mix it up a little bit. Go with a pink. Alright, so we're going to do joint A. And typically what I'll do is make a little circle. I'll say, okay, this is joint A. Come in, draw that, which is R, A, Y. You want to draw your forces. So what I'm doing is I'm pretty much cutting it right next to it. I mean, infinitesimally small. It doesn't have to be, but that's what I always like to think of it as. And then you're going to have right here, and I always make, and this is force of habit from my from school, is make it look like, yeah, that's terrible. Anyways, I make it look like pipes. I don't know why. I always assume that they come out because that's positive sign convention. You don't have to do this if you have a better way. I suggest you do it this way. This is quite common. And then this one is FAB, because it's going from joint A to joint B, force of AB. And you're going to have the force of AC down here. And that is all the information we need to know. That's all the information we have, actually. So I'm going to change up again. And, well, you're thinking, oh, well, how do I do this? What do I do? And typically in this situation, what you will do is, obviously, well, maybe not obviously, but rotating summing your moments is not going to work because they're all concurrent. They're all going through this point. Therefore, if you made it like that, you sum the moment about point A, you're going to get a lot of zeros. So what else can we do? Well, what do we know? We know that, well, we have a y force here, and we have a straight x force, and this is diagonal. So what you want to end up doing is you want to change this force into, and I don't know, I do not know, but I'll put it over here. But I hope that doesn't confuse you. This is FABX, and this is going to be FABY. And you put it into components. You break this into components. Once you break those into components, you can take a look at it again. Well, since there's no external means these are internal. This is external, the reaction. There's no external x direction. So this right here is going to resist any right there. And this, since this doesn't have any y component, the FABY is the only thing that's going to resist this FAY. So, actually, I'll just go ahead and do the math. The sum of forces in the y direction equals 0, and you have RAY, which is, I should just put 3.5 kips, equals positive 3.5 kips. And then you have, right here, you have another positive. Remember, it's going up, so you assumed it's positive, plus FABY, or I assumed it was positive. It was in tension, equals 0, and you don't have anything else. So you know that FABY, remember, you'll have to bring it over here, or actually you'll bring, subtract 3.5, you'll bring it over here. FABY equals 3.5, and remember, that's a negative. Alright, I'm going to go ahead and stop the video now. Actually, yeah, I'm going to stop the video now, and I will pick it up again on the next video, because I am running out of time.